Hello dear students, in this particular video we are going to learn application of Ampere's law to a straight conductor. Let's write application of Ampere's law to a straight conductor. So if you have a long straight wire and let us assume the current is flowing in this direction, then the magnetic field produced due to this current carrying wire will be circular loop in closing this wire, and let's say the radius of this loop is r, and this loop we call Amperian loop, and at each and every point on this particular loop the magnetic field is directed along the tangent. So now we are going to apply Ampere circuital law, and by using Ampere circuital law we are going to find the magnetic field, magnitude of magnetic field. In place of saying yeah dB will be fine, or we can say also B, because it is better to say B, because we are going to find the magnetic field due to this straight wire, current carrying wire at this point. So this is representing the Amperian loop, or we can say we want to find the magnetic field at a distance of r. So let us call this one as B vector. This is also B vector. So direction is changing, but magnitude will remain the same. Magnitude won't change. So we can say an infinite length wire carrying current I, and surrounding this there will be a circular closed loop. Yes or no? That is representing the magnetic field. So we are going to apply the line integral over this. So the magnitude of magnetic field, the magnitude of magnetic field B is going to same at every point of circular loop. So if we apply B dot dl, so B is magnitude wise constant, B dl into cos, and dl element is also in the same direction. So theta between them will be equal to 0 degree, cos theta. So B dl cos 0 degree, which is 1, B dl, and B is constant, so out of integration dl, and dl will be equal to 2 pi r. So B into 2 pi r. We know this loop is going to enclose this straight wire or conductor, and it is infinitely long. We have assumed it is extending from minus infinity to plus infinity. So now we are going to apply the Ampere's circuital law. So from Ampere's circuital law, we can say the line integral B dot dl will be equal to mu naught times the current which is passing through this particular, the current which is enclosed by this Amperian loop. So this Amperian loop is going to enclose this conductor, and this conductor is going to carry a current of I. So what is the current enclosed by this Amperian loop? I current only, which is flowing through the conductor, and we have already done the calculation of B dot dl, which is B into 2 pi r and mu naught into I. So B value we can directly write mu naught into I upon 2 pi into r. So this is the expression of magnetic field due to an infinitely long wire at some radial distance r from it. And we know that B is inversely proportional to r. So when r tends to 0, B tends to infinity, and when r tends to infinity, B tends to 0. So the graph of B versus r will be rectangular hyperbola in the first quadrant. As r increases, B value decreases. So B inversely proportional to r. So in this particular video, this much only. Thank you.